children year 11, can you see me? Can you see the board clearly? Do I need to bring down the border a little bit? I hope that you guys are all awake. My setting is very simple. I just got the 2 whiteboards from warehouse and I just now attached to my window. And I hope that the effect of the writing, everything's all good. I forgot to turn the live chat on with my year 13s, and now you guys have the live chat, so which is good. So make sure that give me the comments. If you cannot see certain parts clearly, just let me know. And I hope that you guys are super awake and get yourself ready. Can you please make sure that you have your math notebook in front of you? Okay, can I start? Okay, thank you. Okay, I think this is because I'm not sure whether you probably cannot see it. The view behind is actually a mountain. You can get to see some sheep and cows and horses. Okay, now let's start. So, okay, I just locked them into another living room, so you won't be able to see them. Dominic, please stay inside. Thank you. I'm having my lesson now, okay? All right, so let's start. So today, my plan, I slightly changed a little bit because after yesterday's, oh, you can't see the top left? You mean this one? All right, can you see? Can you see now, the top left? Okay, all good. Now let's start. So I picked some questions from yesterday exercise questions. Sorry, not the cows locked in the lounge. As my toddlers now they are in another living room. The cows are free to walk around. Okay. So the first one. Now I'm gonna have a bit of different approach to these questions here. Now we all learned that the fractional power is actually same as the root. Okay, so I can change this one to the square root of 100. And we all know that 10 times 10, which is 10 squared, will give us 100. So therefore, the answer is 10. Now, I'm going to write this in another way so that you can see the effect of the whole thing. So I can change 100 to 10 squared. So this square and the square root here will cancel each other's effect. So therefore, the answer is 10. Now let's have the next one, which is 125 to the power of 1/3. Now, again, we're changing to the cube root of 125. Now you just need to think about 125. What number to the power of 3 will give us 125? And we probably all know that 5 times 5 times 5, which is 5 cubed, will give us 125. And therefore, this power and the cube root head will cancel each other's effect. So the answer will be 5. Now, the reason I'm running this way is it's actually leading really nicely to the questions on the right-hand side board. Let's have a look at the next question here. So you have 16 to the power of negative 0.5. And I can say that this is the same as 16 to the negative half. And remember, when we have a negative power, it's actually same as 1 over the base number, and the power become positive, so it will be half. Okay, now let's keep looking at what we can do here. And I'm going to write on this side so make sure that everyone can see it. So 16, 1 over, now we're going to change the fractional power to the square root. Now for the square root, we don't really have to write a 2 outside because the root head itself, if you're just reading itself, that means square root. Yeah, it's 16. But for today's case, I'm just going to write it so you can see the effect that I'm going to talk about. So square root of, yes, Dominic? Yes, can you please bring it to the other room? Thank you. So 16 is same as 4 squared, and the power of 2 and the square root will cancel each other. So that'll be 1 over 4. Okay? Sorry, gentlemen. Okay. Is everyone following so far? Does everyone know that what we are doing here? I think my daily life is now also trying to switch between math and toddlers and the house chores as well. Okay, so let's have a look at question 5. Now, question 5, I need to look at carefully. So far, all the fractional powers, the numerator is 1. And suddenly you start to see that the fractional power, the numerator, is no longer 1. But what we can do is, remember we learned power of power. So when we do power of power, and make sure you write this down into a notebook as well. So I can say that this is same as 8 to the power of 1/3 and the whole thing to the power of 4. Or I can also say that this is equivalent to 8 to the power of 4 and the whole thing to the power of 1/3. Because remember, the power of power, we multiply the powers together. So 4 times 1/3 will give me 4 over 3. So I actually didn't change the value at all, but I'm just writing a different way to help me to solve these problems. So now, let's just quickly use the second option that we got. So I'm going to use this to continue. So that will give me, I'm changing the fractional power to the cube root to the 8 to the power of 4. All right. So here, let's have a look. I was actually going to use this one, but it's all right. So cube root. Now, not in a hurry to tell yourself what is 8 times 8 times 8 times 8 times 8. Okay, so that's going to be a big number. But just think 8 is what base number to the power of what? So I can easily think of 2 to the power of 3 is 8. So if I rewrite this, this will become 8 to the power of 3 and the whole thing power of 4. Now, this is the interesting part because 2 to the power of 3 power of 4 is actually equivalent to 2 to the power of 4 to the power of 3. Because the power of power, what you do is multiply the powers together. So 3 times 4 is 12, 4 times 4, 3 times 4 is 12. So they are actually equivalent. So if I rewrite this part again, so I can say that this is actually same as cube root of 2 to the power of 4 of power of 3. All right, this part is very important. I want to make sure that you all of you are actually following this. And the reason I actually want at the end the power of 3 is so that I can actually cancel the effect of power of 3 and cube root here. So because I can cancel the effect of cube root and the power of 3, so the answer will be same as 2 to the power of 4. Okay, and then from here you can write, okay, so this is 2 times 2 times 2 times 2, so which is 4 times 4, which will give me 16. So this is much easier than just try to expand 8 to the power of 4 and think about the number, cube root of that number. Okay, so I actually use this question that the way I process here, adopt this into this question. Okay, is everyone getting this? Is my sound okay? Okay, just let me know if my sound is a bit lagging or maybe I just, okay. I probably make sure that I'm facing the laptop when I talk so that you guys can hear clearly. So now I'm just quickly going to erase the left-hand side. While I'm doing that, can you please make sure that, okay, can you please make sure you are actually writing this whole thing down into your notebook If you don't have enough time to write down, that's totally fine. You can come back to this video again. You can just go to this part and then pause, and then you can write. So left-hand side and middle side is okay. The right-hand side is not fine. Our left. Okay, sorry. All right, before we move on to question 4, let's just do one more. Okay, now I know why. I can do this. All right, let's do one more example that is similar to question 5 here, which is also one of the questions that is on your exercise question. So that's question 9. Question 9, 32 to the power of 2 over 5. So now the first thing that I'm going to do is change it to the root format. Okay. So this is actually same as 32 to the power of 2 to the power of 1 over 5. Okay. So therefore, I can write this as the fifth root of 32 squared. Now, because I got the fifth root here, so I will naturally think this number 32, what can I do so that something's power 5 will give me 32? So that's what I would think first. So I know that 2 times 2 times 2 times 2 times 2, 2 to the power 5 will give me 32. So I'm going to rewrite. So that'll be 2 to the power 5. Okay, it's 32. And I still have that power of 2 here. However, just now we said that 2 to the power of 5, a power of 2 is actually same as you switching those two powers, because the power of power, we are always multiplying. So by switching them, doesn't really change the actual value. So I can rewrite this, will become 2 squared to the power of 5. Okay. Now, if you look at it, you have something to the power of 5, and you have fifth root, and they will cancel each other's effect. So therefore, the answer is 2 squared, and which is equal to 4. Okay, that's good. Okay, is everyone getting this? But this is very important because I'm actually going to use this, and we're going to start to solve the question. Yeah. So rather than okay, so rather than trying to expand the big numbers, this way is smarter and quicker. Now let's have a look at the question 4 here, and just take your time to write these things down in your math notebook while I'm erasing the board. Okay, the next question is 27 to the negative power. So you've got negative power of 2 over 7. Okay, let's start from the first one. The moment you see negative power, we automatically know from the previous lesson, we can do 1 over the same base number to the power of the power becomes positive. And all we need to do now is to deal with the bottom number here, which is the same scenario as question 9. So let's have a look. So the bottom part is actually same as 27 squared to the power of 1/3. Okay? And I can change this one to the fractional power, the bottom one. So there'll be cube root of 27 squared. Now, because this is a cube root, I start to ask myself, what number to the power of 3 will give me 27? And we all know that 3 cubed will give us 27. So therefore, I can write this as 1 over cube root of 3 cubed to the power of 2. Now we can keep going from here, and we just discussed that I can swap these two powers because power of power still multiplying, doesn't change the value. So we have 3 squared to the power of 3. So now we have something to the power of 3. So we can cancel the effect of power of 3 and cube root. So therefore, it will give us the answer of 1 over 3 squared. So which means the final answer will be 1 over 1. Okay, so I hope that you want to do math, then please do math later. Thank you. Yeah. Okay, so we got 1 over 9. Okay. Sorry, gentlemen. I told you my little ones, Dominic, will be constantly coming and interrupt our lesson. Okay, now let's have a look at another question. Okay, does everyone understand this part? Does everyone understand the negative power? Okay, so now I'm going to change the question a little bit. Okay, I'll definitely show him to you later, but not now. Let's just finish our lesson first. Okay, so now I have a question. It says x to the power of 3 over 4 is equal to 27. And the question says you need to solve this equation, find the value of x. So when you first look at it, you're like, where can I start? I would say that this question doesn't look nice at all. If it's just a whole number, then it's much easier. Now, we can actually think another way. We want to find the value of x. That's what we want to find. So x itself, the power is 1. Right? X is what we're looking for, and the x itself is just power of 1. So therefore, what can I do to the left-hand side so that I can get x to the power of 1? So that will be my next question. Okay? Now let's have a look. This is what I got. But can I actually do power of 4 over 3 here? And remember, whatever you do to the left-hand side, you must do the same thing to the right-hand side to keep the whole equation balanced. You cannot just do another new power to the left-hand side and not doing anything. So that means on the right-hand side, I can do 27 to the power of same thing as well, which is 4 over 3. Okay, now let's have a look. What is 3 over 4 times by 4 over 3? Okay, just quickly right here. 3 over 4 times by 4 over 3, which is equal to 1. So that's what we are looking for. hold on, it's not multiply both sides by 4/3. You're putting the power of 4/3 on both sides so that you can get the left-hand side because becoming the power of power. So that's why those powers multiply. Okay. Now, what we get is x to the power of 1, exactly what we want, is equal to 27 to the power of 4/3. Now, this is actually a really fun part. I really like this because this is really challenging our thinking. Having a right understanding, solving equations. Solving this means finding what's x. And we know that x has power of 1. So I start to think about what can I do so that I can change the power to 1. And I have to make sure that I actually do the same thing to the both sides as well. And now all we need to find is 27 to the power of 4/3, which is exactly same as what we have done before. And so therefore we can keep doing this. And we say this is 27 to the power of 4 of 1/3. Remember, power is always multiplied together. And now I can change this to cube root of 27 to the power of 4. I think by now, you guys can actually know that this is a cube root and 27. What number to the power of 3 will give me 27? And we know it's 3 cubed. So therefore, I can rewrite this. This will become 3 cubed, but I still have power of 4 here, so don't forget. And now, all we need to do is the power, we switch them. So we have cube root of 3 to the power of 4 to the power of 3. So the power of 3 and the cube root cancel each other's effect. So the final answer will be 3 to the power of 4. Okay. How do you find this question? Do you think this question is quite nice? I think this question is really nice. It's actually challenging our thinking a lot. So this is the one type of question that I want to talk about today, using the exercise that we did from yesterday. And I'm going to talk about one more thing, and that's it for today's lesson. And if you look at it, the question that I give you, the base is the variable, okay? The bottom one is 3 to the power of 4. Okay, sorry, just realized it's cutting off the. Now can you see the bottom part? Okay, good. Okay, now let's have a look at the next question. This equation, like for example, 3 to the power of x is equal to 9 squared. Now, the variable is no longer the base, which is actually makes it slightly easier. Okay, so 3 to the power of x, now the exponent is the variable, and you have 9 squared on the right-hand side. For this case, if the base is a number, we need to start to think, if I want to make sure that two sides are equal to each other, that means both sides must have the same base numbers. Am I able to change this 9 to an exponent form so that it has the base number 3? Okay, so yes, some of you already answered the question. So I can say that 9 is 3 squared, but because I have another square here, do not forget to copy that down. And this will give us 3 to the power of x is equal to 3 to the power of 4. Now, both sides are equal. You have the same base number. You want to make them equal. What else needs to be the same? The exponent. So therefore, x needs to be equal to 4 so that both sides will be equal. Now, this is a lot easier than this case here. Okay. Now, is it better? Yeah, I'm just going to move forward a little bit more. Okay, good. So when the variable is the exponent, we are going to think about how can I change the base to the same ones. Okay, so basically change to the same base. That is our focus when the variable is exponent. When the variable is the base, then it's a different approach. If the variable is the base, then we need to think about, we're looking for x. So how can I make it to the x to the power of 1? And in future, in level 2, you're going to learn log as well. And the log will actually help you to solve some problems as well quickly. Okay, but for now, this is what we are focusing on. Now let's have a look at one more example. And this is what I want you to do in your booklet. So I'm just quickly write the question here. So you have 2 to the power of x is equal to 8 divided by root 2. I'm just giving you a little bit increase the difficulty level, so challenging your thoughts a little bit. Oh, sorry, let me do this. 8 to the power of 3. Okay, while I'm erasing the board, can you please try this question? So the approach will be the same. So if you look at it, the variable is the exponent. So that means on both sides, I want to have the exponent that has the same base. Okay, same base. So left-hand side, straightforward, just 2 to the power of x. So now I need to think about the right-hand side. What can I do so that I can have 2 to the power of something? Basically, I want to change the entire thing to 2 to the power of something. Okay, so let's have a look at one by one. Let's start from the bottom one here. Now this is straightforward because I can see number 2. And it has square root. So that means I can change the square root to a fractional power. So this will become 2 to the power of 1/2. Okay, that looks good to me. Great. But what about the top? I have 8 cubed, but can I change 8 to the base of 2 to the power of something? Can I change to 2 to the power of something? So 8 is 2 to the power of 3. That's what 8 is. And then don't forget, originally you still have another power of 3. So it's power of 3. Now, the right-hand side is becoming simpler, and it all has base of 2. So this is where the law of indices coming in. So the top one, power of power. So 3 times 3 is 9. And the bottom one, we have 2 to the power of 1/2. And remember, when we have an exponent divided by another exponent with the same base number, what happens to the power? We take away. Okay? So therefore, 2 to the power of x is equal to 2 to the power of 9 take away 1/2. Now I have one exponent form on the right-hand side, another one on the left-hand side. To make them equal, all I need to do is, with the same base, make the exponent equal to each other. So therefore, x is equal to 8.5, or you can say 8.5. That's totally fine. Okay, does everyone understand this question? I think all I did is, from the simple example, tweak the right-hand side a little bit so that you can actually practice your law of indices. Okay, so these are actually very nice questions. So what I want you to do today and tomorrow, I'm just thinking about you guys need lots of practice rather than learning a new content. So can you please complete the exercise worksheets that I uploaded on the Google Classroom from the first live lesson? So all you need to do is go to Google Classroom, click on the first live lesson, and you can see the attachment. I want you to use today and tomorrow's time to complete the entire exercise questions. So both page 1 and page 2. And I know that yesterday you guys struggled with quite a lot of questions, and that's totally fine because we went through a couple of them today, and I'm sure now you can actually handle a lot of questions. Okay, so please make sure you do the exercise and practice every single day. I want to say use 20 to 30 minutes today and use another 20 to 30 minutes tomorrow. So tomorrow we are not going to have any live lesson unless if you guys ask me lots of questions and ask me how to solve certain problems, then we'll have live lessons again, and I will show you the step-by-step solving problems. You guys want to see a toddler? Okay. Dominic? Dominic, you want to come here? Stop first. No, stop first. Just say hi. Okay. All you need to do is say hi. Good boy. Yes. Okay, say hi.
Hi, that's nobody.
Nobody, they can see you. Awesome. So does everyone know what to do? So the questions are exactly same worksheet from yesterday. You need to complete both page 1 and page 2. All good? All right. Thank you, gentlemen. Have a lovely day. I'm going to end the streaming now.